In this video, we'll continue our discussion of limits. Notice in this problem, it's different than the rest because this is no longer a surface. It's something in 4 dimensions. We can't even really think about it. We can evaluate this limit, though. We can still get a value. We may not understand the result and what it really means, geometrically anyways, but we could talk about this algebraically. Okay, so now what's going to change is the paths are a lot different. We have 3 variables, so for 3 variables, the paths are no longer going to be just one equation, they're going to be parametric. So paths are parametric equations. I'll abbreviate there. With t. Okay, so with these problems, we're always going to choose an axis, and I'm going to put axis here in parentheses because, not parentheses, but quotation marks, because it may not be an axis. It has to go through the point. So it may not be x equals 0, it may be x equals 5, depending on the point. If this was a 5 right there, I would say x equals 5, not x equals 0. Okay, so let's begin. Let's choose that path that they said along x-axis. So that is when y equals 0 and z equals 0. All right, so that's going to be our first path. That was extremely ugly. There we go. Still ugly, but it's okay. Okay, so let's plug all this into the limit. The only thing that's going to be left is x equals 0. And then we're going to plug 0 into everything except for the x. So I'm going to get x times 0 plus 0 times 0 plus x times 0 all over x squared plus 0 squared plus z squared, which is 0. We're going to get the limit as x approaches 0 of 0 over x squared. Well, using my actual limit formal rules, I got to change that to a 0. Now I can say it's a 0. Okay, so the first path goes to a 0. Now, how we determine this next method, I'm going to call it C. Along the path C, C is going to be defined in a way, I'm trying to match powers. So if I got to change everything to the parametric equations, that's t, maybe we can put t up here for a reminder, to t, it would just make sense to make everything the same power on the denominator so I can get it down to one term. So I'm going to let x equals t, I'm going to let y equal t, and I'm going to let z equal t. Now notice as we plug this in, the limit as, okay, everything is going to, as t goes to 0, all those go to 0, so I can just say t goes to 0. X, y, and z go to 0 as t goes to 0 by the definition that we just made. All right, so we're going to replace everything. On the bottom, I know I'm going to get t squared plus t squared plus t squared. That was the whole point. That's why I did the subs that we did. Now we have to replace, okay, it's x times y. So it's going to be t times t, it's t squared, plus y times z, which is going to be another t squared, and then x times z, which is another t squared. You can tell that this is going to be a limit as t goes to 0, and I don't need to put those together and then simplify. It's the same thing over itself. It's a 1. Then the limit of a constant is the constant. We have found another path that contradicts the 0. So since 0 does not equal 1, the limit does not exist. This will be a bit tricky there. But really, the whole thing is to match powers. Remember, that's what we wanted out of that. If I can get it down to that way, when this simplifies down, it will be one term. That's our goal.